In this lecture, I'm going to show you how to create a hash function. All right, now we are going to create a hash function which is going to be private to our class. All right, in other words, here, let me let's do this here. Let's just do the basic setup for this function. I'm going to do underscore hash, just like this, and it's going to take in a value as an argument. Now, the reason why I put an underscore here is because I want to indicate that this method here is private. In other words, it's private to the class and it shouldn't be used outside of this class here. So I shouldn't be able to do ht._hash to call it. It's private. It should only be called from within this class. All right. Now, realistically, I could use it and over here, and there would be no errors. However, it's just common convention to show other developers that may want to use it that the intention of this method is to be used within this class only. All right, so that's taken care of. All right, and so the purpose, as I mentioned, this is private, so we are going to make use of this function. We're going to call this function for other methods in our class later on, for like set and get. Okay, and what it does is it's going to take in a value. Say, like, if we pass in a value of let's say hello. All right, by passing in hello, it's gonna output and give us a value that's going to be numeric, and that numeric value is going to be fixed, and it's always going to be the same. So if I passed in hello again to the function, it should output or spit out the same exact value. All right, and that value that it spits out to us is going to be what's called the key, and that key is what's going to be the location within our array here, in which the key value key value pair is located within. All right, so the purpose of this hash function is to generate a key for giving us the location within this table or this array for which something is located with. So here, if we look at this over here on Google, some images, you can see that we have these keys that you can imagine that John Doe is passed as an argument into that underscore hash function, or as it shows here. So this is the hash function, so it's passed into here, and the output for, let's see, John Smith, it's showing that the output is a number of 2, and that 2 is going to be the location or the index for our array in which that John Smith is going to be located with. All right, so again, the purpose of that hash function is to create a key or an index for which it's going to be used for the location within our array. Let's see here. So here's another image here. So as you can see here, if well, in this case it uses a numeric value, a number, but in our case we're going to use strings. So if I push in John Smith here into this hash function here, it's going to output the number 4, and you can see here this is the array here, and since this hash function generated the 4, it's saying that at location, the index of 4, that's where we're going to place the value. All right, that's the location. All right, so that is the purpose of the hash function. All right, so let's go ahead and generate this function here. All right, the first thing I'm gonna do is let's see here. All right, so here's our pseudocode. Set up variables for prime and key. Okay, so we are gonna have a variable called prime, and this I'm gonna give it a prime number. Now the reason why I'm using a prime number here, we're gonna use it later on within our method, within this function, to do some calculations, and it just helps minimize collisions. If you do want to see a list of prime numbers, okay, so here, prime numbers list. Over here you can see that there's a list of prime numbers that you can make use of. All right, so I made use of 31. Okay, so just know that the purpose is because it's going to help minimize collisions. All right, so the next one was, let's see, also for key. All right, so we're going to do key. And key initially is going to be set to 0. And it will be the output of this function. So here, I'm just going to do return key. All right, so we don't forget later on. So just take care of that for now. All right, so next, we're going to loop the length of the argument list. All right, so this is the argument here. So this is going to be, say in this case, it was, say, hello. All right, the value is hello. All right, so we're going to loop through that for let I equals 0. So long as I is less than the value. All right, this right here, the length of it. So in the case of hello, that would be, let's see, hello has 5 characters, right? So H, E, yep, 5 characters. So this is equivalent to 5. And then each iteration, we're going to increment the I. All right, so as we enter this loop, we're going to calculate the new key value. Okay, so I'm going to have key here. And the way we're going to do this is we're going to start by doing key multiplying the prime number here, so essentially 31, and the value that we get as a result of that, we're going to add to it the value.car code at the index. All right, now what this method does is it gives us a value for each letter. So here, if I show you here. All right, so the car code at method returns an integer value between 0 and 65,535. All right, and this is represented the UTF-16 code here. All right, so for example, in this case here, it has this sentence here, and let's see. So here it has sentence car code at index. So for the first, the intention of this thing is each character has a numeric value here. So for example, in the case of our method, I said hello. If we pass in the value hello, and we're going to make the first loop, which is going to check the first letter, which is in lowercase h. All right, and now look, we have capital letters, and we also have a section for lowercase letters. All right, so if I look for lowercase h here, and you look to the right, this is the value of it. This is the UTF-16 character, and that's what that method, the car code at, is doing for us. So it is searching for each character, and it's giving us a value of the character here. So in this case, H is going to be 104. So if I was to go back to this method here, as we're doing the loop, because remember, this loop is gonna allow us to go through each letter one at a time. So the first loop is gonna go and evaluate the H. In that case, that's what this is doing here. So we saw that the value for H is 104. So we're gonna get the value for here, and on top of that, we're gonna add in 104. All right, so that's what that's doing. And then the next loop that occurs is going to check the letter E, and of course we're going to check, it will go through that list and see what's the value for E. All right, and the same thing until the very end. All right, and then finally here we're going to add the modulus symbol and do modulus.this.table.length here. All right, now this is the table that we're referring to, the length of the table here, which by default we set it to a total of 53 available slots in our array. So this is modulus of 53. Now the purpose of the modulus is that this ensures that this is no more than the length of, this is one value less than the amount of slots available to us. So here we have 53. So by doing the modulus here of the table length of this, it ensures that whatever the output of this hash is going to be no greater than 52. So it's one less than this value here. So it would be 52. Okay? Because again, if we have a total an array with a length of 53 slots, it wouldn't make sense that the output of this hash function would be, say, for example, 70, 70, which we don't have that amount of slots, so it wouldn't make sense. So we have to ensure that whatever value we get from this hash function, that it gives us a key or an index location for which we want to place inside this array. All right, so that's what the modulus symbol does. And again, the prime just helps with minimizing collisions, because we could have other values that we plug into this this hash function to end up getting the same key value, and so that's called a collision. And so for this, the prime number helps minimize those collisions. All right, so here eventually we would, from doing this calculation here, we would get a key. Oh, and by the way, I just wanted this modulus, in case, let me just further explain that. So the modulus, it gives us the remainder of something. So say over here we get we do 13 modulus of let's say 5. How many times does 5 go into 13? 2 times, and it gives us a remainder of 3. And as you can see here, so the modulus gives us a remainder of something. So if I was to do 13 modulus of 2, modulus of 2, all right, it gives us a remainder of 1, right? Because it will go into 12, leaving us a remainder of 1. All right, so that is the purpose of the modulus. So what's going to happen is this calculation would occur, and then eventually we'll divide it by this, giving us the remainder of whatever that is. And each iteration, it would, as you can see here, it's storing it in the key here, and essentially we're summing up all the values each time we go through the iteration, and at the very end, once the loop finishes, we're going to return that key value, which would be the location in our array that we want to store something within. All right, so that is the purpose of our hash function. So if I save that here, let's go ahead and test this out here. All right, so I'm going to do a save. All right, so I'm going to do HT, and again, realistically, this is a private function, but again, this is supposed to be private to this function. But again, the purpose, I just want to show you guys what would happen if we pass in value to this hash function. All right, this is just to show you, but it is considered a private function. All right, so here, as you can see here, this hash function, if I pass in hello, I get 11, and if I passed in hello again, it will get me 11 hash 11. So that would be fixed. All right, no matter how many times I put in hello, I would always continue to get the same key value. Okay, but now what if I add 0 to it? And remember, as a matter of fact, let me show yeah, okay, well, let me continue to show you this. All right, so what if I add another O to this hello? You see here, it gives me 28, so I get a different value. And what if I added another value, another O to that? As you can see, I get 25. So as you can see, that the hash function is working right now. And also on top of that, as I mentioned, that this key, the output should be lower than the array length. All right, so you see here, so far it's showing that it's less than the 52, or because it should be the array length minus 1. That should be the maximum value we should get from this key. So this is all less than that value here. What if I change this though, the array length here, to be, let's say 5, because I just want to show you something. I'm going to save that, clear this. Okay, I gotta refresh this here. All right, now going back, so now you see I have an array length of 5. That's the amount of slots I have available in my array. So you can see it's not too many slots, so we're obviously gonna get a collision, right? So let me show you. So if I did ht._hash and then passed in hello, let's see what we get. Hello. Oh, no, I gotta let me do this here, run this code. All right, now let's do ht_hash and pass in hello. You see I get 2. All right, so again, you're gonna see that it stays under no more than 4. That the output of this hash function is gonna give us no more than 4. All right, so if I did this again, it gives us 2. What if I add another O? You see it gives me 3. If I add another O, we get 4. Add another O, all right, get 0. So you see it doesn't go above 4. If I do another 0, it gives me 1. All right. If I do another 0, I get 2. So now at this point, you see that I had 2 repeated. So that's considered a collision, even though the input is different. You see, because the first input, or you see here, is 1 O, it's just hello, and then we get the same output of 2, but it's with more O's over here. All right, that's considered a collision. So, and you know, in that case, we kind of expected it because we don't have that many locations or slots within our array. It's only 5. So that was the reason why I wanted to show you, is that we could have these collisions, and we're gonna have to resolve that. And I will show you later on, as when we create our set method, how we're going to resolve that. But again, as I mentioned, the prime number, giving a prime number here when we're doing our calculation, and also when we're setting up an array with an array length, it's ideal that you set up give it a number that's prime also, because this would minimize the collisions. All right. All right, so there's that. So we have a functional hash function that's we're going to make use of later for our methods later on in this section.